Hello, everyone, and welcome back to my online teaching platform. We are still looking at how best we can get solutions or answers to 2025 WASSCE question. That is core mathematics or general mathematics. We have one of the compulsory questions here, and we are to get a solution. All right. So, from the top of a lighthouse 100 meters high, the angle of depression of two cargo ships are observed at 48 degrees and 36 degrees. The foot of the lighthouse and the sea level are on the same horizontal, and the two ships are on the same side of the lighthouse. A. Illustrate the information in a diagram. B. Find the distance between the two ships and leave your answer in the nearest meter. All right. So let us identify the key part of the given statement. We have a lighthouse, which is 1,000. Sorry, I'm saying 1,000, which is 100 meters high. Then we also have angles of depression, okay, of the two cargo ships. That is from the top, okay, angle of depression from the top. Then we also have the foot of the lighthouse and that of the sea level on the same horizontal. The foot of the lighthouse and the sea level are on the same horizontal, okay, and the two ships are on the same side of the lighthouse. So let us illustrate the given information in the diagram. So let us assume that this is our sea, okay, this is our sea level, okay, this is our sea level. Now it is given that the foot of the lighthouse and that of the sea level are on the same horizontal, okay. So it implies that the lighthouse, the foot of the lighthouse will be having a point of intersection, okay, will intersect the sea at a particular point. All right. So let us bring our lighthouse first. Okay. So I want to draw my lighthouse, and the lighthouse has a height of 100 meters. So this is the foot of a lighthouse, and it is on the same horizontal with the sea level. So I can label the foot of the lighthouse as A and the top as B. All right. Okay. Now we also have two cargo ships on the sea, and these ships are on the same side of the lighthouse. So I want to place them at the right hand side of the lighthouse. So we can indicate one of the ships here because the ships are on the sea. I hope you know that for ships they always travel on the sea. All right. Okay. All right. So here will be, I can name the one I can name one of the ships as C, and I'll name the other one as what? D. All right. So it implies that one of the ships is here and another one is also here. Now let us determine our angles of depression. So the observer will be here. Okay. When it comes to angle of depression, the observer will be at the top. Okay. So the observer is here. Right. So this is the eye level of the observer. Eye level of the observer. Okay, so before the person can observe this sheep, the person has to turn his or her eye in a particular direction to get the exact angle that will enable him or her to observe the cargo ship at point C. All right, so we are going to get our angle of depression by connecting point B to that of point C. All right, so that's what we'll be doing here. Let me do that. Okay, then we have another one at point D, another cargo at point D, cargo ship at point D. So Still need to connect that one also to where the observer is, the eye level of the observer. All right. So let us look at this one as well. So we have two of the angles. Now you should know that from here up to here, I mean, okay, you should know that the whole of this angle is 90 degrees, right? Since the eye level is parallel to the sea level, so the angle y is 90 degrees. Now the first angle of depression is 48. So you can say we have one of the angles here and another one also here. But looking at these two angles, you can say one is bigger than the other. So from this point up to this point, we have the bigger angle y. So here will be the 48 degrees. And the smaller, that is from here up to the first line. The line connecting B and D will be 36 degrees. All right. So we are going to apply alternate angle properties. Alternate angle properties to get the angles on the sea level. All right. So when you look at line BD, all right, line BD, you can see that this line, the angle over here is the same as this angle. Considering the Z shape, look at this particular one, or you can consider this one as well. So the angle, the inside one here will be equal to this one. All right. So the angle 36 y here is the same as this angle y. So here is also 36 degrees. Then the bigger one y, that is the angle between the eye level, that is the initial eye level, and that of the new eye level. The new eye level that is now observing the cargo at point C is 38 degrees. So when you consider this particular shape, the shape over here, we are going to get this angle also to be 48 degrees. All right. So when you have two angles of depression at the same side, the bigger angle is closer to the vertical. The bigger angle is always closer to the vertical. All right. So this becomes the diagram for the given information. So we have to illustrate the given information in the diagram. So we are done with the first part of the question. So we are moving to the B part of the question. All right. So the B part says that we should find the distance between the two ships. So we have here, because one of the ship is at point C and the other one is also at point D. So the distance between them is unknown. So we can use X to represent the distance between these 2 points. All right. And that is the distance between the ship at point C and the ship at point D. All right. Now you could say we have two triangles. We have triangle ABC and triangle ABD. Okay, you could say triangle ABC is inside triangle ABD. Okay, so we need to find AC first, because for you to find the X, that is the distance between C and D, you need to consider the bigger triangle. And the bigger triangle has the base, okay, the base as AD. And the AD comprises of AC and what? CD. So you need to find AC first using the smaller triangle, that is triangle ABC. We always deal with right angle triangle so that we can apply either Pythagoras theorem or one of the trig ratios. All right, so we are dealing with triangle ABC for the smaller triangle, which is a right angle triangle as well. So I have my 90 here, A, B, C. We have here to be 100, and we don't know A, C, so we leave it, but we know the angle here to be 48 degrees. So we can now find AC using one of the trig ratios. The side facing the angle automatically becomes the opposite. So the height of the lighthouse is the opposite. Then AC becomes adjacent. Okay, adjacent. The hypotenuse is always the longest side, and that's the side facing the right angle, the 90 degrees. So this is the hypotenuse. Okay, but we don't need the hypotenuse in this case. So we need to find the adjacent. So we have to identify the ratio that involves the adjacent and opposite. So SOHCAHTOA. So it's going to be tan. Tan is opposite over adjacent. So we are going to work with tan 48 degrees will be equal to AB divided by AC. All right. So our AB is 100. So we have tan 48 is equal to 100 divided by AC. All right. So we have AC tan 48 is equal to 100. So what do? We divide through by the coefficient of AC. So it's going to be tan 48, then here 2 by tan 48. All right. So yeah, this tan 48 divides this, we are left with 1 multiplying AC. We have AC is equal to 100 divided by tan 48. So let us look at it. So 100 divided by tan 48. So we are getting the answer to be 90.04. So we have 90.04 meters as the distance between the foot of the lighthouse and one of the cargo ships. Okay, so now we can now bring back our diagram. Okay, the diagram was in this form: A, B, then there's C here where one of the cargo ships is, then another one is D. Okay, so D was here. So now we have here to be 90.04. Okay, but we don't know the CD, and that's what we are supposed to find. We know the height of the lighthouse to be 100 meters. Okay, we know our angle here to be 48 degrees and here to be 36 degrees. So what do? We now consider triangle ABD, the bigger triangle, and we have to apply one of the trig ratios. So considering angle 36, the side facing angle 36, looking at the angle 36 will be, we always work with the right angle triangle. Okay, you can never use angle BCD. Okay, when you are applying the trig ratios, the trig ratios work for only right angle triangle. So we are considering the bigger triangle ABD. So the side facing the angle 36 is 100. Okay, so we have 36 degrees is equal to opposite, which is AB, divided by adjacent. So adjacent is AD. Okay, that is A to D when you consider the bigger triangle. So we have 36 is equal to 100. This is the opposite, divided by AD. But you can see that the AD comprises of AC and CD. So we know our AC to be 90.04. Okay, 90.04 plus CD, which is X. Okay, let's go back and look at it. So we have this plus this, giving us the distance from A to what? D. Right. So the distance from A to C is 90.04 plus the distance from C to D, which is X. And that will give us the distance from A to D. So that's what we have done over here. So 90 plus 04 plus X will give us the distance from A to D. So we can now cross multiply. So we are going to get tan 36 multiplying 90.04, because these two terms are binomials, because we have two terms that we are adding, we have to put them in brackets. So 90.04 plus X should be in bracket, all equal to 100. So we are going to get 90.04 plus x in one bracket multiplying tan 36 all equal to 100. All right. So we are going to expand the bracket with tan 36. So let's find tan 36 first. So tan 36 is 0.73. 0.73. So we have 90.04 plus x multiplying 0.73. All right. 0.73 equal to 100. So we multiply the 90 by 0.73. So sorry, 90.04 rather. So we are getting 65.42. Then plus x also multiplies 0.76, which is 0.73x, all equal to 100. All right. So we now make x a subject. We are going to get 0.73x equal to 100 minus 65.42. So we have 100 minus answer. Okay, so this will give us 0.73x equal to 34.58. All right. So what do we do now? We divide through by the coefficient of x. So 0.73x, then here to be by 0.73, all equal to 34.58, also divided by 0.73. So when 0.73 divided itself, we get 1. 1 times x will give us x. Then you also divide the 34.58 by 0.73, right? And this will give us a result of 47.37. 47.37. So this becomes the distance between the two ships. Okay, looking at this one, we have the distance between the two ships as x, which is from C to D. So we conclude that, and we have to leave the answer in the nearest meter. So therefore, the distance between the two ships is 48 meters. All right. Thank you for watching. Bye.